Hello everybody, welcome to my programming channel. My name is Howie Reith, I'm a software developer, and today we're going to be talking about Redis, specifically as a representation of key value store databases. For those of you who don't know me, I make these videos because I am really passionate about becoming the best developer I can be, and I figure one of the best ways to do that is to share what I have learned with others, to solidify it in my own mind, and hopefully help out the community. If you have any questions about this video, you can email me at howard.reith@gmail.com, or of course feel free to just drop a comment on the video itself. Here's what we're going to go over. We're going to go over how to install Redis on your computer, talk about some create, read, updates, and deletes, some of the more complex data types Redis has to offer, talk about Redis's implementation of transactions to a degree, then a couple advanced things, Redis's pub sub feature, and some configurations you can set for some specific use cases. So let's get it installed. Go to redis.io/download, download whichever version of Redis is appropriate for your environment. I am going to be doing this tutorial on Ubuntu 20.04 via Windows Subsystem for Linux. Now, when I boot it up, I do redis-server, which is already running over here, and then to access it, redis-cli. When you see something that looks like this, when you have the IP address on which you are running the Redis server and your blinking cursor, you should be good to go. So once you are in that state, feel free to go forward with this video. So let's talk about Redis. Redis is an exceptionally fast in-memory distributed data structure. It is written in C, and for the most part, it is a hash table. If you are familiar with the hash table data structure, you have a pretty good idea of how Redis works under the hood. In terms of CAP theorem, it prioritizes availability over consistency, and it supports a variety of data types. We are not limited only to strings or whatever. We do have access to some slightly more complex data structures. And Redis is a pretty simple piece of software. It is only 20,000 lines of code. So if you are looking for some C code to devour for a really good example of well-written code, I highly encourage you to check out the Redis repository. So the advantages of Redis lie in its speed and simplicity. If you need to write complex queries, if you have a complex data structure, Redis is not the correct database for your use case. Common use cases for Redis are caching. Indeed, there's a fair number of people who think that that is the only purpose it serves. Also, since it is highly available and very fast and supports very simple situations, it is often used for chat apps, and it is very good for keeping track of user sessions. So let's talk CRUD. So for starters, let's just make sure the server is up and running. You can just type in ping, and it should respond with pong. And if you ever have a situation where you're not really sure what's going on, you can simply type in help, and it will give you some more information about how you can dig in and get more help. So let's set our very first value. So to set something, you conveniently use the keyword set. We are going to set our key equal to fruit, and we are going to say that the fruit that we are setting is banana. Boom. Okay, we have successfully set our very first key in Redis, and then if we get fruit, it returns to us the string banana. And then if we want to delete the fruit, boom, it tells us, hey, I have deleted one thing for you, and if I were to try to get fruit right now, it is nil. Alright, thank you for watching my tutorial. That is all that you ever want to do with Redis, and yeah, I am of course kidding, but seriously, if you are doing a lot of complex stuff beyond just get, set, and delete with Redis, you are probably using the wrong tool. Remember, simplicity here. If you have to get clever, you probably need something more complex than a key value store. Alright, let's get into some more stuff. Let's say you want to set multiple keys at the same time. Redis supports that with this little command here called mset. So fruit, banana, vegetable, green bean. Voila, I have set two keys at the same time. I can get my vegetable, boom, it is a green bean. I can get multiple items at the same time. I can get fruit and vegetable, boom, boom, banana and green bean, bada bing, bada boom. Cool. Redis stores the data you pass in as strings, but it recognizes when a string contains an integer, and you can perform some mathematical operations on items that are obviously integers. So for example, if I were to set number of 5 and I were to get number, if you see here, that number that we are getting out of the database is returning as a string. It is not being saved as a number. However, if I were to run the increment command on number, it will increment it by 1 and get us the value of 6. But still, nevertheless, you'll see if I get number again, it is returning a string value of 6. So just be aware of that. You can do some numerical operations on numbers in Redis. However, they are being stored in the database as strings. So this is additional logic that is happening. All right, moving on. Let's talk about some complex data types. So Redis's complex data types list includes lists, hashes, sets, and sorted sets. And they can contain up to 2 to the 32 elements. So that's probably more than you are ever going to need. Let's start with the Hashmap, or hash table. You can think of it as all of those. You can set a value inside of a hash with the keyword HMSet. So let's create a user inside of our database. And we are going to give him the key of user:1. And then the first key inside of user:1 is going to be name, which we are going to set to Stephen. And then the second key is going to be password, and we are going to set his password to password1. So notice that the key we set has multiple pieces of information. We have identified that it is a user, and we have identified the user as user1. I encourage you to think in these terms as you are setting keys and values in Redis. Remember that though you are able to have a layer of complex data types, for the most part, everything in Redis is going to have to be a string in some capacity. So Stephen is a string. Password1 is a string. Even the numbers that we were setting in the previous example, they are strings, okay? So you can have a list of strings, but you can't have a list of lists. You can't have a hash map of lists. And if you ever want to try some voodoo, where like you have a bunch of keys that are all complex data types, and then you do some sort of for loop to access every single one of those keys via a list of keys inside of Redis, you're thinking too complexly. You have a use case for a document database, you should probably use a document database. So think in terms of keys, right? We can still structure our data in a relatively complex way by simply using delimiters. In this case, we're using the colon to say user:1, right? So think in those terms. How can I cram more information into my keys and values in a way that I'll be able to parse once I have retrieved stuff out of the database? So to retrieve a value from a hash map, you can get all values by doing hvals, and you can get all keys by doing hkeys. And if you want to get a specific value at a particular key, you use hget. So I'm going to get the name of user1, which is, of course, Stephen. To retrieve the number of fields in a hash, you can do hlength. So we have 2 keys inside of this hash map. And to delete a field in a hash, you use hdelete. And I have deleted password, and so if I were to get hlen now, it is down to only 1. Let's go over the list data structure. Lists in Redis can act both as queues, which is first in and first out, and as stacks, which is last in, first out. You can also insert into the middle of a list, constrain its size, and move values between lists. To create and push into a list, we're going to use rpush. That stands for write push. We are appending to the end of a list. So let's go ahead. We're going to take Stephen, and we're going to give him a bunch of interests. So we create our list and push the very first value in with rpush, user1 interests, and we are going to say he's interested in climbing, StarCraft. There we go. We have created our interests list. So if we wanted to prepend to the list, instead of doing rpush, we would just do lpush. So let's try lpush, user1 interests, and we're going to add hiking to Stephen's interests. To retrieve the length of the list, we use length or len. So len user1 interests. And to retrieve a portion of the list, we use lrange. And this is probably going to be the one you're going to use most often. So you can specify the first and last positions you're interested in. Note that Redis uses 0-based indexes, so the start of the list is going to be at 0. So if I do lrange user1 interests, and I get from 0 to 2, we're going to see the very first 3 things that we brought in. If you want to retrieve the entire list, instead of doing a final range like that, you can just do -1 at the end, and that will give you the absolute entire length of the list. To get an element at an index, you can use lindex. So lindex user1 interest, we're going to get the very first thing, and that should give us hiking. To get the index of an element by value, you can use lposition. So if I want to find out where hiking lives, I can do lposition user1 interests hiking, and I find out it is indeed at index 0. To insert at a given value, you use linsert. So user1 interests. I am going to insert before hiking the value of cooking. So now we have 5 items in there, and if I were to look at the lindex of 0, it should now be cooking. To set the value of an element at an index, you can do lset. So if I want to set user1 interests, I want to replace cooking with baking, and then I look at that, I now have it set as baking. To remove and return the first item in the list, you can use lpop. So this is thinking of it as our stack. So lpop user1 interests should give us baking. And if I want to think of it in the other side, grab the very last thing and take it off the list, I'm now going to get football, which was our last item. So if we now check out the length of user1 interest, it should be 3. When we want to remove an item from the list, what we do is we first say we're using the lremove function, LREM. We do the key that we want to remove it, the key of the list, how many items we want to remove from it. So for example, if you have multiple iterations of a particular value inside of your list, how many of those iterations do you want to remove? And then the string that you want to remove. So if we do this, which I just ran, we're going to remove our one example of hiking. And then if we do the length, we are now down to 2. Let's talk about sets. Sets are unordered collections with no duplicate values allowed in them, and they allow for you to perform some complex operations such as unions and intersections. To create an unordered set, we use SADD, so set add. Let's start by creating a set containing our chat room names. So we're going to add a set called chat rooms, and we're going to name our chat rooms general, gaming, and sports. To view members of your set, you can use set members. And now that we know how to do sets, let's just go ahead and delete our users' interests and replace it with an unordered set. So he is interested in gaming. So now let's find the intersection between these two sets. We want to identify what interests our user has and what chat rooms match this user's interests. So we are going to use the sinter, the set intersection command with chat rooms and user1 interests. And look, we have identified we have a chat room called gaming and he has an interest called gaming, so that is a chat room that he might be interested in joining. We can also find where they don't overlap with set difference, chat rooms user1 interests, and we can build a union between the two sets with union. So if we want to do union chat rooms and user1 interests, this would produce a list or a set of all of the items combining these two. So all of the overlap plus, think of it as the Venn diagram containing absolutely everything. Lastly, if you want to store the result in a new variable, you can do union store. We're going to call this new variable chats, and we are going to make it a union of chat rooms and user1 interests. So if we were to now do an members of chats, voila, we have our 3 values. If you ever want to find the length of a set, you can use cardinality, which is going to return, as you can see when I did it right here, a value of 3. And since sets are not ordered, but there is no left or right end, if you pop a value from it, it's going to be just a random value out of the set. So if we did spop, as I did right here, you'll see it randomly selected the gaming value to pop out of it. If you want to remove a specific value from a set, then you simply identify the key that you want to remove with srem. So chat rooms, I want to get rid of general. So if I were to do members of chat rooms, it should only have sports left. So most of the data types we've talked about so far are probably data types with which you are relatively familiar. Next, we're going to talk about a somewhat different one, which is a sorted set. which is based on both the list and the set. Sorted sets are like lists in that they are ordered. They have values that are the indexes of the list, but they also contain unique values in the sets. You cannot have any duplicate values inside of a sorted set. They have key value pairs like hash tables, but rather than using strings for the keys, they have numbers denoting the order of the values, the priority of it. So they are essentially a random access priority queue, if you're familiar with that data structure. Sorted sets must maintain order, so they are O log n to insert rather than constant time, as is the case with hashes and lists. So let's get to the meat of our chat room application. We're going to give it the name General Chat, and we are going to set it up as a sorted set. Each entry is going to have a key equal to the Unix timestamp in milliseconds, and a value equal to the username and their message delimited by a $sign. So for example, our first message is going to be this Unix timestamp, and then we're going to say that it was user1 who sent it, and their message is going to be, hey, what's up? So to insert into a sorted set, we use zadd. So Z for sorted set as opposed to S for just a set. So let's grab our message right here and paste it in, and voila, we have created our first sorted set. If you want, you can even add multiple messages, multiple entries to your sorted set at once. So we're going to say user2 has said not much you, and then user1 has responded just chillin'. Alright, moving on. To retrieve the values from our general chat, we can use zRange. To get all values, you can do a range from 0 to -1. Otherwise, set the range of indexes to whatever it is you will want. It will return in order of their position. That is, the order in which they were added, not the order of their scores. So if I were to do a zRange of general chat, 0 to -1, voila, there's our 3 messages. Now, if you want to get it with the scores, with the timestamps that we've been adding, you can do the zRange with scores, and it will alternate. So the first one is going to be the message and then the score, right? So to get our values in order by score, then we have this other command here called zRange by score. And so this is just going to be, we want everything with a score from 0 to a very large number, in this case 99999, and now it is going to be ordered by the timestamps that we have been using as our keys in there. It happens to be the same order, but it is not necessarily. So this can, of course, retrieve a subsection of the range as well. If you only want to get a specific slot of time, you can do that. If you want to get absolutely everything and you don't want to pick an arbitrarily large number like I just did, you can do -infinity to +infinity. And if you want to get them in reverse order, you can do z reverse range by score and get them that way. Lastly, if you want to get a union between multiple sets, say, hey, we have multiple chat rooms and we want to get all of the messages that are in all of these chat forms, all of these chat rooms, you can do zunion store. This works just the same way as sunion and sunion store. If you know those, you know this. We don't need to get into it right now. Now, one very common use case for Redis is as a caching layer, and usually it's as a companion to another database to reduce how often you need to perform expensive queries. For this and similar such use cases, Redis's expire command is extremely valuable. So what expire does is it will make it so that the key that you set will vanish from the database after a set amount of time, usually articulated in seconds. So for example, I am going to set a value right here called will expire with the value of bye-bye. I'm going to set expire to expire in 5 seconds. And then if I check this right now, I see that, well, expire does still exist. And a few seconds later, voila, it has expired. It no longer exists in our database. This is such a common use case, in fact, that Redis has an even more niche command called setX, which will set and set an expire time at the same time. So if I do set expire of this same key right here, and then if I check to see if it exists right now, but a few seconds later, it is gone. To see how much time an expiring key has left, you can use TTL So if I want to do a set x of this will expire right here, I can do ttl will expire, and I see that as of pasting that into my window right here, I had 7 seconds left, and right now I have 0 seconds left. And indeed, it expired it is just -2 from now on. Now, by the way, if you change your mind and you want to keep this key, you can do your set expire, and I'm going to do this one right here. I have 20 seconds, and then if I take that key and I give it the persist command, and then I were to check ttl won't expire, it is never going to expire. To clarify, if you do ttl and you get a result of -1, that means it exists, but there is no expiration value whatsoever. If it's -2, that means the key no longer exists. To mark an expiration for a specific time, there is a command called expire at, which will accept a Unix timestamp in seconds. So I am going to go ahead and visit this website right here, and I'm going to set will expire by. And I'm going to change my will expire to this plus, let's say, this is in seconds, by the way. So I'm going to give you a little bit more time. Let's change you to 5. So expire at will expire in this amount of time. And if I do ttl will expire, ttl will expire, I have 2,954 seconds left until I hit this timestamp. One really common use case for this is session storage, right? So user logs in, they have a particular token that is set to expire at a certain amount of time, and let's say every time they perform an action on the application or every time they refresh the page, you want to reset how long it's going to be until their session expires. Very simple way to do this. All you are doing is modifying the will expire time every single time they refresh inside of your database. Let's talk about how Redis does transactions. So remember, Redis is not an ACID database, okay? It is not particularly concerned with being really good at transactions and data integrity. However, it does support it to some degree. And the way it does it is with the multi-command. So let's say I have this num to increase right here, okay? Set num to increase to 5. I start off my multi-command, and what Redis is going to do is it is not going to execute any of the commands that I am typing in here until I have run the execute command. It is just going to put them into a queue, and then as soon as I have done execute, it's going to go through that entire queue and do every single thing one at a time. So I'll just demonstrate that for you right now. I'm going to increment num to increase, increment num to increase. You can see that it is queued. And when I execute it, it is going to execute it, and you will see that that value is now equal to 7. So one thing I do want to note about this, it is not going to block any other users from modifying this. So for example, if I were to start that transaction, and somebody were to go into my database and modify that value from 5 to 7, and then I were to execute that increment, and I were to go and look at it again, it would now equal 9. Okay, the fact that I have started my transaction has not blocked anybody else from modifying that value. So it is entirely possible that somebody else messing in this database could cause an error in the transaction that I'm attempting to run, or change the value, and I'm going to get a value that I didn't necessarily expect. But this is a mechanism for locally, I can make sure that all of my commands are being run in a unit, as opposed to having to type them in one at a time, and perhaps something I don't expect to happen could happen in between. Also be aware that at any point while you are working on your transaction, you can run the discard command. And while Postgres would do a rollback, as in it would go back and undo each of the things that it already executed, what Redis will do instead is it simply has this queue, it just never executes the queue. It discards the queue, boom, you don't need to worry about it at all. Alright, let's move on to our very first advanced feature of Redis, which is the pub sub. So let's imagine our chat application has many users and many chat rooms, and we want to have users who can choose which chat rooms they wish to subscribe to. And then they will receive notifications when the new messages come into these chats. So this is like Slack, Discord, etc. So to implement this, we're going to use Redis's publish subscribe functionality. Subscribe allows a user to subscribe to a particular key, known as a channel. And subscribing to a channel will cause the Redis CLI to block, so you'll need to open another window in order to do this. So I'm going to subscribe to something we're calling pub sub chat. So you can see now I am subscribed to pub sub chat. Now coming up, I'm going to publish a command to this channel. So in this other one right here, I'm going to do redis-cli, just connecting to my normal one right here. And I'm going to publish, hey, it's a message to pub sub chat. So I see that I have published this now, and if I were to go over here, hey, it's a message has appeared inside of my subscriber in this other window. You can have a functionally unlimited number of people subscribed, so every single user who is subscribed to this channel right here would have received this message. Now note, there is no persistence in Redis pub/sub. These values that are being sent across here, they're not being stored in memory, let alone on disk. So if there's anybody who fails to receive this transmission, they're just going to lose it forever. There's nothing you can do. And nothing is being saved in the database, so you can't play back everything that has ever been sent to this pub/sub. So just be aware of that. This is not functioning as a database. If you want to be saving messages, you're going to need to do that in addition to the publish subscribe that you are using with Redis. All right, let's talk about configurations. So part of the power of Redis lies in its configurability. You can change it and alter it to fit exactly the use case that you have for your data store. For now, we're just going to focus on a few things that you are probably going to be particularly interested in. If you ever want to know about general configurations for your current system, you can use the info command. I'm not going to do that right now because it's going to fill my screen with all sorts of stuff that I don't necessarily want right now. So to look up a specific config item, you can use config get, and this will return the value of the key name that you type in. If you want to get all of your configurable configurations, you can just do an asterisk as so, and I will demonstrate. Boom, we have everything here. Let's say I wanted to get save in particular. If I did config get save, it is going to return these particular values here. And if I were to do config set save and this, it is going to change my configuration immediately. And every single command I run from that point forward is going to be using the new configuration. You can set default configurations in a redis.conf file, which is going to be living in /etc/redis. So you can modify that with Vim or whatever text editor you prefer. So let's talk about persistence. So you'll notice in the previous example, I was dealing with the save configuration. The save configuration concerns how frequently the Redis database actually persists the data to disk. So remember, it's an in-memory database. That's where Redis gets some of its speed from, because it is readily available right at top-level memory. If you want to actually be saving this stuff to disk, that is going to take a little bit more time. And the way Redis does it by default is it periodically persists what it has in memory to the disk. So if you take a look at the current configuration here, the way this works is if I have updated 3,600 keys in the database, I am going to persist to disk in 1 second. If I have updated 300 keys in the database, I'm going to persist to disk in 100 seconds. And if I have updated only 60 keys, I am going to persist in 1,000 seconds. You can set this to be whatever you want it to be, for whatever level of safety you feel comfortable with. Because remember, you are playing a risk here. In the event that your Redis database were to lose power in the middle of running your application, if you haven't persisted to disk in an hour, you're going to lose all of the activity on your application for the last hour. So if that is unacceptable to you, you should save to disk more often than that. But then again, the more often you save to disk, the slower Redis is going to run. So you need to decide the trade-off between speed and reliability. So you can find out the last time Redis saved by doing last save. It's going to give you a Unix date value. If you want to manually save, you can just use save. voila. And then if I check last save, it is just now. And then if you want to do background save, what that's going to do is that it's going to asynchronously save in the background in much the same way as save, except it's not going to block anything if you have a lot to save. Generally speaking, it's best to simply set your configuration for whatever save frequency you want. If you want to set up your app to save literally after every single thing you do, or if there's some commands that you're really concerned with persisting, you can do saves immediately after those. That is completely up to you. Definitely something to consider. Let's talk about replication. So, Redis, highly available database. Chances are you want to do everything that you can to make sure that your users are able to get their data as quickly as they can possibly get it. Oftentimes this means replicating your database across multiple nodes across large distances. So Redis supports master-slave replication, which is when one server will be the primary server responsible for reads and writes, and all other servers will only be capable of reads. To create a replication, this is pretty simple. What you need to do is not inside of the Redis CLI, but just in normal bash, go ahead and copy your redis.config file into another file name called redis-s1.conf. And we're going to make one or two small modifications inside of redis s1.conf. We are going to change the port to 6380 instead of 6379, so there's no conflict there. And we are going to say that it is a slave of, and then your IP address, and then the port number of the master Redis server, which by default is 6379. Then go ahead and boot it up with this new value. Once you've got it booted up, go ahead and get into it with Redis CLI, and you can set the port value with 6380. We can go ahead and just make sure it's up and running on my machine. It is indeed with ping pong. So let's go ahead and just go into it. So this window I have right here is inside of our slave. This window right here is still inside of our master. So inside of the slave, if I were to try to set a new key, you're going to see that it is set for read only. We do not have write access on this. However, if I were to try to do the exact same thing on the master server, voila, I am able to do it. And then both on the master server and on the slave, I am able to get it. And also note that this isn't simply redirecting values, right? This isn't a proxy. I can go over to the master and I can shut it down, and then I can go over to the slave and I still have access to it. So the database has been replicated inside of the slave. It's just, it doesn't provide you with any write access. If you want to do writing, you need to be going to the master server. So that is basically everything I have to say about Redis for this video. Thank you very much for watching. I learned basically everything about this video from 7 databases in 7 weeks, and the Redis docs and the Redis articles on Tutorials Point. So if you want to learn more about Redis, I highly recommend starting with these 3 resources. Once again, thank you for watching. If you have any questions, you can feel free to email me at howard.reith@gmail.com, and you of course are welcome to comment on this video. Thank you very much. I hope this was helpful. I will see you next time.